Hey, we're back. So when we the last end of the last video, we had finished the intake design. And what you'll see is this song looks a little bit different than when we left it. So I did a little work offline um, to try and figure out how everything was going to get laid out. So the intake is done. Now we're working on the pivot. So you'll see some parts in here that I was just kind of playing around with as far as positioning, but as far as the pivot goes, this is what I was thinking. So let me turn off the bumpers, and I'll explain to you what I'm thinking. So basically, all this upright here is 2-inch box aluminum extrusions. What I was thinking here is we would just come straight up from the inside front crossbar of the frame of the robot and just come straight up. So what that does for us, it gives us the ability to mount straight into the aluminum extrusion for the crossbar, gives us some rigidity. And the other thing that buys us is it allows us to move the pivot forward. I didn't directly measure what we were looking at, the movement forward of the pivot of the intake, but it absolutely positively does clear our swerve modules. So we've got full range of motion. The other thing that I was looking at is if you look at this is an FRC battery. I just was able to find a model online and throw it into the front or the back of the robot to see how it packaged. And I'm thinking that's a really, really good place for it, especially if when, not scoring, the the robot is out picking up a part. Having that battery in the back would be a great counterbalance to everything that's all that weight that's cantilevered out in the front. So when we're picking this part up here like this, having that battery in the back would be really, really, really good for us. The other thing that I did is I brought in a second set of scoring because I wanted to see what it would look like if we came to the scoring table or the scoring station in a little bit different position. So we're a little bit higher instead of being down here, way down low shooting. That allows us to go get a little bit more elevation and gives us another opportunity to score. The other thing, and I have not checked this part out yet. Let's see what we look like at the human player station. Wow, that actually looks pretty darn close. So if we look at, I'm not going to be able to see it very well because it's off side to side, but if we look at it from the left side, if we drop a part down, there's a halfway decent shot. We could get a part straight into our intake. So this pivot position is actually really, really, really good for us. So we're going to stick with it. So now, how do we go about making the pivot in CAD? So I'm going to turn the battery off, turn the, what is the scoring? Turn that off. Okay. I'm also going to open up the intake as well. I'm not sure if we'll need to, but, so again, all I did with this to create this is I just simply created a box that extends out of the belly pan, 2 inches by 2 inches, and I came up way too high. And then once I got it in position vertically, I shrunk, or the height, I shrunk it back down. So it's got about 1 inch past the pivot. And then the other thing I did was I did a shell command. And what that does is it allows you to create a hollow box out of the box we created. So this is 2x2, 1/8 inch wall, really, really thick, should be pretty sturdy. So now all we have to do is go about creating the holes for the bearings. Now to do that, it should be pretty simple to do. So what I'm gonna do is I'm gonna create a sketch on this plane. We're gonna capture position as we always do. Right, and then what I'm going to do is I am going to turn some of these bearings off, because what we're going to do is all copy. Actually, I don't. All I need to do is this. So we're going to project that outline of that polycarb onto the surface of the upright. Okay, it's as simple as that. So then all we need to do is finish the sketch. Now to be safe, eventually what I'm going to do is I'm going to push this circle all the way through the 1, 2, 3, 4 walls. But to be safe, what I like to do, if I don't want it to go through like this hex shaft, I always turn the parts off. So we're going to turn our intake off for the time being, and then I'm going to press it through, or extrude it through. So I'm going to go through here all the way through, make sure we're on cut. You can verify that with the red profile, and then I'm going to click OK. So our sketch goes away. We're going to turn on our intake again, make sure everything's still in one piece. Great. Okay, so then we need to follow through with copying some of these bearings over. I don't know how well because these bearings are currently in this sub-assembly. I don't know how well, I'll be honest, how well copying a bearing from the sub-assembly and putting it into the main drawing is going to be. So all we're going to do is we're going to insert a brand new one. Thankfully, I've got it over here in my parts list. So we'll drag and drop one of those in, and it is way over here. So we're just going to move it to where we can see it at least. And then we're going to start getting it into the right orientation. Got to rotate it 90 degrees. And then once I get it into the right orientation, I'm going to do again a point to point. And we'll zoom in here. We want that circle on the back of the flange to line up with this circle. All right, that's good for one of them. And then all I'm going to do is select it again. I'm going to hit move, M for move copy. I'm going to create a copy. And this is going to be easier because then I can just do the corner point of our aluminum structure there. And again, create copy didn't stick. So let's reselect our origin point. And we do have create copy. There we go. Okay. So that's 2 out of 4 bearings. I'm going to do it again. M. This time I'm just going to do a free move. Oop, not capture position. Create a copy. I'm just going to move it over. Get it out of the way so I can reorient it, because I got to rotate it 180 degrees to get it to fit on the other, for the other flange. Now we'll do a point to point again. And we want We want that surface to line up with that surface. Click OK. And then we got one more to make. We'll do that one. Create a copy. Select the point there, there. And we're going to go OK. Okay, so our bearings are in. Now we have to figure out the motor and pulley setup. Okay, now that we got the bearings in, we have to actually add the motor and the pulley setup. So we're going to cheat a little bit. I'll get to that in a minute. So we want some big pulleys on this thing, and by big I mean wide, to make sure we contain, we got enough surface area on the belt. So the pulley I chose for this is a 30 tooth by 15 millimeter wide. So I've already downloaded it from West Coast Products, and so we'll drag it on in to our design. So it comes in the wrong orientation, so we have to put it there, and then we will do a point to point. So what I'm going to do is I'm going to pick the center point there, and then we're going to come up here, and for now, just going to pick the center point here. Okay. So that's our first pulley. Okay, we're going to go ahead and add more eventually. But here's where we get to how I'm cheating. So before this season coming up, really the only kind of real way would have been to mount a motor on one of these outside flanges, and let me turn the cube off. Mount the motor on one of these outside flanges and go all the way through both of these tubes with hex tubing, and then mount our pulleys here. We're cheating though, because there's a new motor out there that just got unveiled from Rev. It's called the Neo Vortex, and the cool thing about this motor is it allows us to, it's a through bore motor. I'll open it up and show you what it looks like. What this does now, it's not only a self-contained motor controller and motor itself, but it's got a planetary gear set in it and all that. So, but now what we can do is we can just pop a hole into our tubing and go ahead and run hex shaft all the way through the motor, and get essentially as many pulleys as we want on this thing. It compacts things up a little bit, but figure out where we're going to put that motor. We're going to use that belt calculator again. So let me pull the belt calculator over again. Actually, first, let's kind of guesstimate about where we roughly want this motor. So now if we have a pulley out here, we're kind of constrained by this swerve module here. We can't go down and crash into the swerve module, so we need to keep clear of that swerve module. So let's just measure and see how far away from that swerve module we are. So I'm gonna pick, let's do snap points and millimeters, and then we'll go from there, and then let's pick the center line of there. Okay, 180 millimeters as the crow flies, but we need to figure out how far vertically. So we're about 160 millimeters. Okay, 160.5. Let's fire up Notepad and just write that down. So 160 160.5 millimeters. So we know that much. And we also know the diameter of that, of the pulley. And if you give me a minute, we'll figure it out. All right. So this is the pulley that we use, this 30 tooth, 15 millimeter wide. All right, so the outer diameter is 51 millimeters. So half of 51 is roughly 25. We'll call it 26, so minus 26 millimeters. So then that leaves us with about 135 millimeters. And we'll give ourselves a little clearance, so about 100, let's call it 130 millimeters. Okay, so what I'm doing is I'm coming from the center line of our pivot down, calculated that to be about 160 millimeters, and then it came up a radius of our pulley, and then gave us a little bit more room. So I think we said 130 millimeters. So now we can come into the belt calculator. Okay, so I've already got this set up for 5 millimeter pitch. Units are millimeters. We're going to put 30 teeth on both sides. And then we said about 130 millimeters is our desired center. So it's looking like, and we're going to err on the side of caution. We're going to go a little bit shorter just to give us a little bit more room down to that swerve module. And we're going to make it 125 millimeters. So that's center to center, 125. So we're going to fire up Notepad again and make sure we don't forget that we want 125 millimeters. Okay. So that's essentially what we just did, is we calculated where this other pulley is going to be. And then much like we did with this upper, we're going to throw a hole in and push it all the way through both uprights. So to do that, I'm going to do a sketch. We'll do it down here. Okay. So because I created a sketch on this plane, it's already got the hole in there. So we can come down from the center line of that hole. You can see it's a little hard to see because all of our parts are still in the way. We can make it a little easier on ourselves. So if I come, and now it's selecting the center of that hole, and I want to come down 125 millimeters. Okay, so that 125 millimeters, that is where our hole needs to be. Okay, so we're going to finish this sketch. Now, I can't recall exactly how big these holes are, so we're going to measure that one. And it is, diameter is 28.575. We're going to create a cylinder on there, and that's not working. All right. I love how I can't interact with a sketch. All right. So we're going to do this the hard way. So if you recall, down here, 25 or 125 millimeters down, and then we got to come out 28.575. That's the diameter of those bearing holes. So we'll finish that sketch, and then we'll extrude it, and we're going to pull it all the way through. Make sure we're through that. Should be good. Okay. So that's it. So far we've got the bearing holes. So now what we're going to do, we're going to turn those bearings back on. Okay. Now what we can do, those 4 bearings, we're going to copy them down to our new holes. Move. We're going to create a copy. And in this case, we can actually do a free move. So we'll come down here. And remember, we had 125 minus 125 millimeters. And it didn't do the copy. But we're going to do this again. We're going to reselect those 4 parts. Remove. Create a copy. I'm going to select that direction, 125 minus 125, and there we go. Now, going back to our pulley setup, we want to copy this one over. We're going to add a whole bunch of pulleys. Probably have too many of them. So we're going to select that guy. We're going to create a copy of that one. And we're just gonna, it doesn't have to be perfect. The reason we're copying this over is to make sure our spacing down at the bottom clears. We're going to double check our calculations in real world. All right, so that one is now aligned. Now what we're going to do is we're going to create a copy of that one. Heck, we can create a copy of them both. Let's do that. Move. Now we're going to do a point to point this time. Okay. This time we're going to select the center line of that bearing, and believe it or not, even though we got it on a front view, if I'm selecting that edge, it's going to default to the center of that bearing. So I select that first point, and I come down, select there. Looks to be good, at least from the front. And it didn't create a copy. No matter. We will just create a copy. But the important part was it looks like we got clearance down here. So we're good there. So let's just move, create a copy, select our bearing again. There. To there. Okay, it actually created the copy. Fantastic. All right, so we got a lot of our pulleys set. We'll come back to this side, this pulley side, in a minute. Now, what we have to do is we have to get that motor in. Okay, so we'll go ahead and drag that motor in. The model, when I downloaded it from Rev, had a whole bunch of wiring and different types of shafts. I've already gone into this file and turned all that junk off so that we literally just have to only worry about the actual can of the motor. So we'll spin that way. Oops. 90 degrees. And then I'm going to rotate it this way. 90 degrees. Just to try and get it oriented. Okay, so now we got it in the right orientation. The one thing I do want to do, I'm going to turn some of these bearings off because we don't need a bearing where we mount the motor. We don't need a bearing. So I want to make sure that I align the face of the motor up with the hole I created. So now I'm going to pick the center line of our shaft there. And I'm going to line it up with that center line. Looks good to me. Now what we can also do, check our positioning. It looks like I can see all the way through from one pulley through the aluminum, another pulley, and then through the motor. So everything looks to be lined up. Okay. The last thing we want to do here, well, almost last thing, is we now have to add some pulleys over here. So let's turn those bearings back on. Okay. So what I'm going to do is I'm going to select that one. Actually, let's change this to component priority. So I'm going to select those two those two pulleys, and I'm going to move them on over to the other side. Make sure we're creating a copy. And in this case, we can just use the corners of our aluminum like so. Okay, that is awfully good. So again, we've got our 125 millimeters for our belts. We've got a decent amount of, so these are 15 millimeter wide. We got a whole bunch of belt contact. We'll get, these motors are really strong. So I have no reason to think that in a design like this, nothing would slip or anything like that. So the last thing we got to do is add some hex shaft to go through. I'm going to skip adding stuff like the clamp collars and stuff like that. It's kind of trivial for what we're doing in these videos. So I'm not going to go through the clamp collars and, excuse me, stuff like that. But we do have to add the hex shaft going through. So let's see roughly how far it is. We'll go from this surface on over to that surface. Let's 300 millimeters. Well, that's meters. Why? Inches. So it's about 12 inches. Thankfully, I got a pre-made 14-inch piece of Thunder Hex in my library over here. We'll drag one of those in. All right, so let's get it in the right orientation, 90 degrees. And then we'll do a point-to-point move. We'll pick the center line there. And then, yep, center line here. All right, so it's lined up. And then all we'll do is another free move to just kind of even it out a little bit. Close enough. Yep, that's even. So there we go. So again, we've got the pulleys very close to our bearing surfaces, which is ideal. We've got some fairly thick wall aluminum there, so I don't see any issue with as far as like tearing the aluminum or anything. We got more pulleys than we know what to do with, so it's going to be pretty strong. The only thing, and this is something we might have to consider later on, is some sort of triangulation. Because if I let me turn the intake off. Boring. Can't even find the intake. There it is. Okay, so what's going to happen is we're going to want to figure out a way to add some support for these uprights coming down to the belly pan, because this is going to see, like, if we only support it and fasten it on one side, that whole thing is going to get stressed going forward fairly significantly. So what we're going to have to consider doing is adding some triangulation coming back down to the belly pan to try and support it going the other direction. That probably will be later on after we figure out, because I mean the important thing here too is we got to find a place for all the other components down on the belly pan. So the last thing I want to do with this is, now that we've got this whole upper structure done, I want to try and organize this stuff a little bit so that it's easier to work with. So I mean, I've already started doing some of it, like this rolling chassis is one component, the intake, the bumpers are one component. So I'm going to show you how to create components, and basically all it is like a folder setup. So what I'm going to do is, I've got the main the highest level of our parts tree selected right now, and then so what I'm going to do here is come up to assemble, and then new component. Okay, so what'll happen is the parent is the top tree. Okay, so it's already been selected for us. We'll fix the name here in a minute. The thing I want to caution you is uncheck this activate box. I don't know why Fusion does that. It kind of makes things look weird and can confuse you a little bit. So I always uncheck the activate box. So when I click OK, you'll see here this component 234 was created. So first, let's fix the name. So we're going to put everything related to that pivot in this component. So we're going to call it pivot uprights. Just you click on it and then click on it again, and you can rename it. So then at that point now, it's everything that we essentially added this video. We're just going to drag it from the part tree into that folder. So drag the hex, pulleys, our motor, and if I wanted to control click and select a bunch of parts at the same time, I could. Again, whenever this capture position or revert position comes up, I always choose capture position. Okay. We'll control click our way through to make things a little bit easier. Okay, so you'll notice that essentially everything is in there except for these uprights. And the reason being is I created those, just created those as solid bodies. Okay, so they are buried here under this bodies. Okay, so we'll just control click those and drag them in there. So now I can turn on and off the pivot uprights very, very easily and very quickly.